Hi, I'm Byron Anderson, and I'm a PE.
Hi, I'm Ted Corless, and I'm a JD.
You are listening to the PE JD podcast.
Byron, we've got some fun stuff to talk about today. I'd get us off of the issues associated with infectious diseases in the public. And let's talk about this issue of how we go about repairing sinkholes, especially if we're talking about repairing sinkholes associated with multi-unit buildings, either fourplexes or sixplexes or 25-story plexes, and see how we go about examining the engineering issues associated with that. Byron, let's jump into talking about how we go about assessing what an appropriate repair would be for a sinkhole property.
Well, we always have to start talking about the proper repair methodologies with what is considered the standard of care. As an engineer, the standard of care governs what we do along with Florida statutes in this case. It's also applicable to other parts of the country, but the standard of care as set forth in Florida statutes is that if an insurer identifies sinkhole activity at a property and there has been a sinkhole loss, then the insurer is responsible for paying the costs to stabilize the land and building and repair the foundation. So those words, stabilize the land and building and repair the foundation, becomes our directive as an engineer on how to develop the appropriate stabilization process. And going back to what we talked about during one of our earlier podcasts, we understand that sinkhole activity and sinkhole conditions start at the limestone surface or the horizon of the limestone, and they are the result of dissolution of that limestone because of groundwater, eating away at the limestone. So keeping that in mind and keeping the first tenement of a sinkhole repair project in mind is to stabilize the land, then we have to come up with a method in which we address those sinkhole conditions at depth. And the only tried and true and proper method which stabilizes the land is what we call compaction grouting or low mobility grouting. And in the process, go ahead.
And that's the grouting. Sorry to interrupt there. All right, so the compaction grouting is some form of, it's a fluid. What is that? What's in that fluid when you go to compact it or to grout a property? What's that made out of?
Well, it's a cementitious material. So grout is cement, water, and sand. And sometimes there are some admixtures that are added into the grout to make it more flowable, make it more workable. But generally speaking, when we talk about grout, it would be cement, water, and sand mixture. So during the grouting process, the first thing that we need to do is be able to come up with a method in which we can deliver the grout down to where the soil is weakened and or voids have formed. So our delivery method that we use is we drill steel pipes, typically around 3 inches in diameter, into the subsurface at routine spacings around the structure. And we also alternate between vertical and inclined points. The reason that we're doing this is we want to get around the perimeter of the structure with our primary points, but we also want to get underneath the structure with our secondary points. And so after we've gone around and drilled our pipes down into the surface of the limestone, it's important that we get it into the surface of the limestone. Then we step back and we take a moment and we look at where the points have been drilled around the structure, and we want to start, it's very important here, to grout from the deepest point that we have. So if you think about what we're doing with this compaction grouting process, is we are going to pump the cementitious grout material into the soil or into the limestone, and it really has 3 purposes. The first purpose is it's going to seal off the surface of the limestone to create a cap on the limestone to hope to arrest future dissolution of the limestone from the groundwater. The second thing that's going to do is migrate and fill in voids that are in the limestone and directly above the limestone interface. And then the third thing that the grout is going to do is it's going to increase the density or compact the soil that has been weakened due to the effects of sinkhole activity. Um, and so once we drill all of our grout points in, then we find the deepest point, and then we start grouting at that location. And we pump grout into the subsurface until we reach a certain limiting criteria, typically high pressure or lift of the structure. And once we get to those limiting criteria, then we pull the pipe up out of the ground a small increment, typically between 2 and 5 feet, and we start grouting again. And ultimately what we're trying to do is make, in an idealized picture, almost like a string of pearls that would be coming up out of the ground surface, where each one of those pearls would be a volume of grout that has filled voids and compacted the soil. One of the problems with compaction grouting is that you're pumping this grout under tremendous pressure, and as it gets near the surface, that grout wants to take the path of least resistance. And generally speaking, between about 15 and 15 feet below a building and 20 feet below a pool, we start to become concerned that that grout is going to make its way to the surface and uncontrollably heave a structure. And I certainly have seen my fair share of improper grout jobs that have damaged buildings tremendously. And so in ordinary grouting scenarios, we limit how close the grout can be installed to the surface to about 15 to 20 feet. So that leaves a zone of unimproved soil from the bottom of the foundation to that negative 15 to negative 20 foot mark. And so we have a secondary type of grouting that we use in that scenario called chemical grouting, in which you are, in ordinary sense, you're taking a two-part chemical material, a polymer, and you're combining them together, and they interact with each other and expand, almost like great stuff does that you get from Home Depot. And the expansion that occurs during that process, again, fills voids and compacts soil, increases the density of the soil underneath the foundation, and we're able to control that better so that we're not as concerned about uncontrolled heave of the structure. So that brings us to the third tool that we have in our toolbox associated with sinkhole remediation. And again, going back to the idea of stabilizing the land and building and repairing the foundation, and that is underpinning. Underpinning, in a typical sense, is taking a steel bracket and attaching it to the foundation of a building. And then once you attach that steel bracket to the foundation of the building, you use hydraulic jacks to advance steel pipes through the bracket down into the subsurface until you get to a strong bearing stratum, a stable bearing stratum. And you do these underpins one at a time, and then once you've completed the underpinning around the structure, then you can hook them up with jacks in a daisy chain scenario back to a manifold, and you can uniformly lift the structure back into place. So underpinning is used for a couple different reasons. Number one, we can lift and restore a structure that may have excessive settlement that has occurred to it associated with the sinkhole conditions. Number two, again, the standard is to stabilize the land and building and repair the foundation. Well, if you have other deleterious soil conditions, we talked earlier in other podcasts about organics, debris,
or
clay soils.
Right.
All of those conditions need to be addressed as part of the standard of care in order to stabilize the land and building and repair the foundation. So the underpinning system may be used to bypass those clay soils or those organic soils. And you also may have conditions which are slope stability issues that you would incorporate underpinning. And finally, for underpinning, there may be sinkhole conditions that are so bad at a site, or a history of dropouts or cover collapse sinkholes that have occurred at a site, that you are concerned that during the grouting process and moving the soil around during the grouting process, you are going to cause additional damage to a building. And so in those cases, you may underpin a structure for preventative reasons. And then finally, in the toolbox, there are some hybrid systems that may be used, or these systems may be used together with each other. One of the probably most common Sinkhole remediations is compaction grouting with chemical grouting, but you may also have a combination of compaction with underpinning of exterior walls and then some chemical grouting on the inside to fill voids and lift slabs. So they can be used together. And then there are more pure hybrids out there like injection piers.
Yeah, I've got a note to ask you about injection piers.
Yeah,
I'll get to that.
So there are other hybrids out there. So yeah, that's kind of a recap of the technology and the engineering thoughts behind stabilizing a sinkhole affected property.
Well, let me come in and start asking you some questions about each element of that. Lots of information, and I guess what I would want to do is to put myself in the shoes of a homeowner, or say you're on the board of directors for a condominium association, or you're a property manager for a property that has had a sinkhole loss confirmed on the property. When you go to hire someone to do this kind of work, are you hiring an engineer to come in and do it, or are you hiring a contractor that specializes in injecting concrete in the ground as you've described it?
You're hiring the contractor that's actually going to perform the work itself. In most instances, and it's highly recommended, you also hire an engineer that's what's called the monitoring engineer that oversees the project. And the reason you want somebody to oversee the project is because the contractor is typically going to get paid on a unit price contract, meaning that for every linear foot of grout pipe he drills into the ground and every cubic yard of grout that he pumps into the ground, he's going to get paid for that amount of work. Well, as I said, he's putting the stuff into the ground. So it's not like building a house or doing a remodel or an addition where once the contractor is complete with the job, you can go back and check his work. This stuff is, 30, 40, 50, 60, sometimes over 100 feet down into the ground. And so you need somebody during the installation of those materials to be keeping track of the quantity of material that's being used, and then also providing oversight to make sure that the contractor is providing specifications. I'm not aware of any public building official or building department that provides any sort of oversight associated with sinkhole remediation projects.
Right. It's just very much under the standard of care as you described it. They do the things that they think are in best practices for grouting a home, and if they work, great. If they don't, well, got to move on to something else, I guess.
Correct.
Now, when you're talking about injecting something 100 feet away, some of the houses I suspect you've investigated that distance, if it were laid vertical, or pardon me, if it were laid horizontal, could be longer than the perimeter of the home.
Sure.
And what if the sinkhole activity that's actually causing the damage to that particular home is not exactly right below the structure? How does that affect the grouting process?
Well, that's one of the beauties of the grouting process is that the grout is being forced under pressure into the subsurface, and it's going to migrate to find those weak zones. So it's going to move towards the weakest areas. But it's very important that during this grouting process, we keep in mind that, if we're grouting 100 feet deep, well, we may be 90 feet below the water table. And so there's a lot of water that's inside of these voids. So whenever we talk about voids in the subsurface, you got to kind of keep in the back of your mind, we're not talking about a void that just has air in there. It's a void in the rock and in the soil that is infilled with water. And so one of the most important things with this compaction grouting process is that we need to find those zones, but then we have to slow down the grouting process so that grout has time to displace the water out of those voids and then fill up the void and improve the soil. What we generally try to do with the vertical points is create a curtain around the structure that is a curtain of improved soil. And then with the incline points, we're directing the grout underneath the interior of the structure so that if there is sinkhole activity off-site or further away from the building, first of all, hopefully we've got enough grout to migrate over to do some improvement there. But the second thing that we're doing is we're creating a strong curtain in between that weakened soil condition and the building to protect the building.
Got it. So if I'm imagining a wall on a building that's being grouted, it's the idea that we're going to take a plane and it's going to go down into the soil. And I guess the idea is by putting these injection points across the wall, then you're kind of creating a wall that just kind of keeps going down into the soil. Is that the way you're describing it?
Yeah, it's, we refer to it as creating a curtain wall because it's not necessarily a straight plumb wall like it's on the building. It's more, it's a curtain of grout around the perimeter. And again, that grout's going to be somewhat uneven. But there are problems, associated with this grouting process.
And this idea of the thickness of the concrete and installing it under pressure, would you say that with some regularity that efforts to grout a home fail?
I would say that, yes, absolutely. I've investigated hundreds of properties that have been remediated. I've had the benefit of going back and doing additional SPT borings at many of those properties where I found suspect grouting conditions. So, let's redirect it a little bit here. I start to look at a house that has been grouted previously. Well, the first thing I wanted to look at is what was the original geology and geotechnical testing at the site. Was, what kind of sinkhole conditions did it have? How deep was it? Did they have other deleterious soil conditions? And then I look at the grouting or remediation program. Was the appropriate remediation program selected for those site-specific geologic and geotechnical conditions? If they selected the right remediation method, now did they perform that method appropriately? One of the big things I see is that we'll have a void from, say, 45 to 60 feet below a structure, and they install their grout casings, and all their grout casings stop at 40 feet. Well, they didn't even get down into the area of the soil that needs to be improved. Or there's a void from, let's say there's a void from 40 to 45 feet, and I start looking at their grout records. They started grouting at 48 feet, and they pulled up their pipe to 38 feet, so they've pulled past that zone that needs to be improved. And probably one of the biggest things that I'm finding when I'm looking at these remediation, these properties have been remediated, is they're simply pumping the grout too fast. Again, what I said a while ago is I have to slow down the process to allow the water to dissipate out of the matrix of the soil, so that can be infilled with the grout, and the grout can do its job. If you are pumping the grout too fast, you may be getting high pressure because you haven't allowed that water pressure to dissipate in the soil, or you could have high pressure that all of a sudden drops, and that's an indication that you've fractured the soil matrix. And so slowing the grouting process down is very important. However, if I'm a grouting contractor, I'm getting paid a lot of money to drill these grout pipes into the ground. And if I have the right equipment and the right crew, I can get a lot of grout pipe put into the ground. As soon as I'm done with this grouting project, I get to pull that grout pipe out, take it to another job, and reuse it. So that's a reusable material that I am getting paid, $17, $18 a linear foot to install that grout pipe into the ground. It's a lot more work, and it takes a lot more labor and a lot more equipment to inject the grout into the ground. And so if I have to slow down that grouting process.
Yeah, I think that was a Freudian slip there.
Yeah, absolutely. If I have to slow down that grouting process, then I'm eating into my profits, and
Sure.
I don't want to eat into my profits, So there is unfortunately, economic incentive to grout as fast as you can, even though from an engineering and a performance side, I'm saying you need to slow it down and do it appropriately. So going back to your question earlier, we've tested hundreds of properties because I have suspect problems based on my review of either the type of remediation that was done or the process of remediation. And probably 80% of the retests that we have done have found unimproved, ongoing sinkhole conditions.
Now, you kind of leaned into a really important question here, and that is, I'm assuming if the grouting contractor is being paid by the units of concrete, it would be important for someone who were hiring that contractor to have some element of predictability regarding how much that's going to cost them.
Sure.
Are you able to prepare? If I owned whether it's a individual single family residence, or if I'm on the board of for a larger building with more multi-unit buildings, how is it that they are able to make an educated decision on whether they can afford to undertake the process that you just described?
Well, it's very difficult because, as you know, Ted, whenever we are doing our investigation and we find sinkhole conditions, then we estimate how much material it's going to take to remediate the sinkhole. But that is just that, it's an estimation. And that estimation is based on, number one, our knowledge of the grouting process and the underpinning or whatever it may be process. It's based on the site-specific geologic conditions. It's based on regional geology. So there's all these factors that come in, and we are preparing an estimate, but that estimate is based on somewhat limited knowledge, meaning that an SPT boring is only about 2 inches in diameter. A typical residential site might have 3 SPT borings done at the site. So on a percentage basis, you have a very small snapshot of what's going on at that location. And so we're estimating to the best of our ability, but we've certainly seen grout jobs that go over 200%, go under to 50% of what we estimated. So we're doing our best job to get a good estimate together, but there's an awful lot of unknown associated with it.
I mean, I guess the analogy I'm kind of thinking here is people might make the mistake of believing that grouting a structure is equivalent to someone pulling up to a gas station and filling up their tank. You can't see the inside of the tank, but you do know generally, we would be able to know by looking at your manual for your automobile how many gallons there are that it would take to fill it up. But here, you're creating an estimate based on certain scientific premises that could be wrong. And if they are, you've got an individual who's hired a grouting contractor and they say, we're going to put 300 cubic yards of grout underneath this home. But then when they actually attempt it, it's 600 cubic yards. Does that happen with some regularity?
Yes. I would say more often than we would like to, it happens. And we're constantly trying to adjust our processes to eliminate the frequency of that occurring, but it certainly does happen.
Well, I guess I'll jump in and play lawyer for a moment here, and that is that I would tell anyone who's undertaking, is sitting down to assess what would be an appropriate method of repair, especially if it's a group of individuals who have multiple buildings that are multiple sites on a property. It's not uncommon in Florida to see 40 or 50 buildings that are spread out. And the geological conditions from one on the north side may be entirely different from the south side, which means it's so important for you to be comfortable that the engineering estimates are accurate. Now, if you are in the middle of an insurance claim, it's going to be a little bit different. But here's the important point. If you're spending the insurance company's money, and I don't mean that in kind of like, hey, spend their money. No, I'm saying if they're the ones who are ultimately going to have to pay the bill for the grouting, that's a far better situation to be in than many times I've seen claims where an insurance company just hands them a large sum of money and walks away from the project. Now, at that point, the insured is the one who's going to be on the hook if the estimate turns sideways. And I encourage you to go to our website at corlessbarfield.com and invite you to subscribe to our podcasts as we continue to produce them. We enjoy producing the content, and we always appreciate the feedback we get from the public. Be safe out there.